And finally, dear students, we are going to talk about a totally new idea that you haven't known before in previous grades, in grade 8 or whatever. And this idea is about rationalization and conjugates. So conjugates and rationalization is our new idea. It's not difficult at all, and by the end of this presentation and by the end of these videos, you'll be so smart in rationalization and in dealing with radicals as well. You see those signs following us from the start of the presentation. You see here in the denominator there is a radical as well as here. So the aim of this idea is to get rid of radicals from the denominators, and that's what we mean by rationalizing the denominator. So rationalizing the denominator is to get rid of the radicals in it, is to make it a rational number and not with radicals. To rationalize a denominator, we should know what's the meaning of a conjugate. So rationalization is related to conjugates because every time I'm going to rationalize, I'm going to multiply the denominator and the numerator as well by the conjugate of the denominator. Now, what are conjugates? Examples and conjugates. Conjugates are numbers that when multiplied by the radical itself give me a rational number. For example, radical 11. What's multiplied with radical 11 that gives a rational number without a radical? For example, I can multiply radical 11 by radical 11 because when I multiply radical 11 times radical 11, I'm going to get radical 11 squared, which is 11. So to multiply radical by its conjugate, definitely I'm going to get a rational number. While if the radical and the number are separated by a minus sign or a plus sign, then I'm going to multiply, for example, if I have this, a radical and a number separated by a plus sign, its conjugate is not itself, because I'm searching for a number or a value that when multiplied by this gives me a rational number without radicals. So I choose radical 3 minus 1. Why? Let's explain why. If I have radical 3 plus 1 to be multiplied by radical 3 minus 1, applying the identity you've known since grade 8, which is the difference between two squares and so on. This represents a plus b and this represents a minus b. We can take radical 3 squared minus 1 squared, which is 3 minus 1, definitely, which is 2. So as you see, the result is without radicals. So the aim of multiplying by a conjugate again is to search for a value that when multiplied with the irrational value gives a rational value without radicals. So again, the conjugate of a radical is itself. For example, the conjugate of radical 11 is radical 11. If I give you another example, for example, 2 radical 3. So what's the conjugate of 2 radical 3? I should multiply 2 radical 3 by a certain conjugate that gives, after multiplication, a rational number, not necessarily natural, but mostly it's natural or integer. So I choose radical 3. I don't have to choose 2 radical 3. I just look at the radical. So when I multiply 2 radical 3 by radical 3, I will get radical 3 times radical 3 is exactly 3 because it's radical 3 squared. So I will get 2 times 3, which is definitely 6. So when I have a number multiplied by the radical, I just choose the radical itself to multiply with it. But when I have a number and a radical separated by a plus sign and or a minus sign, if I have radical 3 plus 1, for example here, then I choose radical 3 minus 1. I just take the opposite sign in the middle. Okay? So if numbers are separated by signs, the conjugate just changes or takes the opposite sign in the middle. Let's continue more examples. For example, if I have 3 minus 2 radical 5 and 3 plus 2 radical 5, note 3 minus 2 radical 5, its conjugate is 3 plus 2 radical 5. So to sum up, this is an irrational number, this is an irrational number, and this is an irrational number. The conjugates are the numbers that I'm choosing to multiply with these irrationals to get rationals. So the radical itself has its conjugate itself. So radical 11, its conjugate is radical 11. Radical 3 plus 1, its conjugate is radical 3 minus 1. And 3 minus 2 radical 5, its conjugate is 3 plus 2 radical 5. So as you see, you just you just put the opposite sign in the middle. If you have plus, you put minus and you multiply as I've shown you before. And if you have minus, you choose plus in the middle and you multiply them. You can expand if you don't want to use the identity. You can expand 3 times 3. If you put these in parentheses and to find their product, you can expand without using the identity. 3 times 3 is 9. 3 times 2 radical 5 is 6 radical 5. Minus 2 radical 5 times 3 is minus 6 radical 5. And finally, minus 2 radical 5 times 2 radical 5 is 4 times 5, which is minus 20. These are opposites, so I can cancel them, and the result is minus 11. So as you see, the result is an integer, which is a rational and not an irrational. It has no radicals. Now let's continue to take examples on how to rationalize denominators. Before, to sum up, these are the rules. The conjugate of a plus b plus radical b is a minus radical b, where b is definitely greater or equal to 0 because it's under the radical. So as I told you, when the numbers or the values are separated by signs, for example, here you have plus, then the conjugate is the same value but separated by minus in the middle. The conjugate of any radical not separated by plus or minus and so on, is the radical itself. Let's apply the rules, and here are the examples under the title of training exercises. Rationalize the denominators of the following. Here are 4 examples. I'm going to start one by one. The first one, 3 over 2 radical 5. So we have to look at the denominator. The denominator is 2 radical 5. So all what I need is to search for a value that when multiplied with 2 radical 5 gives a rational number. So I choose multiplying by radical 5 up and down. So I choose the radical only. So as you see, I just choose the radical. So I multiply by the same radical up and down, then I will get 3 radical 5, and 2 radical 5 times radical 5 is 2 times 5, so it is 10. And by this, I got a rational denominator. Okay? This value is equal to this value, but they have different shapes only. So if you calculate this on the calculator, and this on the calculator, you will get definitely the same result, but the difference is in its form only. This has an irrational denominator and this has a rational denominator, because I'm multiplying by the value itself up and down, then as if I'm multiplying by 1. I'm just changing the form of this expression. Let's continue doing the other example. I have 3 over 2 plus radical 5. Then think with me, what's the conjugate of 2 plus radical 5? Let's remember, if I have a plus sign in the middle, all what I have to choose is the same values, the same numbers 2 and radical 5, but I have to take the opposite sign in the middle. So what's the conjugate? It is 2 minus radical 5. So I have to multiply by 2 minus radical 5. As you see here, up and down. Now starting to expand, 3 times 2 is 6. 3 minus radical 5 into minus radical 5 is minus 3 radical 5. Now applying the rule that says, don't forget the rule. The rule is A minus B into A plus B. This will save time. You can expand if you want, but this rule will save a lot of time. So all what you have to do is to square the first one, A squared minus B squared, as you see here. So squaring of 2 is 4 and squaring of radical 5 is 5. Thus I got minus 1. And thus I can put minus 1 up. So I will get 3 radical 5 minus 6. When minus is put up, then it reverses the order of the numbers. So we have 3 radical 5 minus 6 as a final result. It is over 1, thus the denominator is rational. And let's continue the last two examples. 3 over radical 12 minus radical 3. Before starting thinking about the conjugate, let's see if there is need to simplify the radicals you see here. So 3 over radical 12 minus radical 3, let's simplify radical 12. It's definitely 2 radical 3. So before starting thinking about the conjugates, let's see if I can make things easier. So 2 radical 3 plus radical 3 is just 3 radical 3. I can cancel 3 by 3, then I will get 1 over radical 3. And thus, I can cancel 3 by 3 to get 1 over radical 3, and thus I have to rationalize the denominator here. I just choose the radical 3 to multiply up and down. 1 times radical 3 is radical 3, and radical 3 times radical 3 is 3, and thus my denominator here is a rational number. Sometimes there's a question that says, show that this expression is equal to radical 3 over 3. So all what you have to do is to rationalize the denominator, and definitely you will get the answer required. And finally, the last example, which is 1 minus radical 2 over radical 12 plus radical 2. Again, I have to simplify radical 12 to write it as 2 radical 3 plus radical 2. See here, they are separated by a plus sign, so I just choose the conjugate, that is 2 radical 3 minus radical 2. So as I told you, and I keep telling you, that to choose a conjugate whenever you have a plus or a minus separating the two numbers is just to choose the same numbers separated by the opposite sign in the middle. And we started expanding. 1 times 2 radical 3 is 2 radical 3. 1 times minus radical 2 is minus radical 2. Here it is minus 2 radical 6. And minus radical 2 into minus radical 2 is plus 2 as well. And as I told you, squaring of the first one minus squaring of the second one. So just squaring of 2 radical 3 minus squaring of 2. So it's 12 minus 2, which is 10. And we keep it like this. I cannot add anything of these values above, so I keep it as it is. Hope you enjoyed rationalization of the denominators. It's very easy. It just needs practicing and practicing, and later we are going to make a lot of exercises to make you very smart and very clever in rationalizing denominators. So these are the ideas of rationalization. This is all what's new about radicals. Hope you enjoyed the chapter, and see you later inshallah in exercises and training exercises.